Okay, here's a review of Cumulative Exam 1. Parts of it I'm going to go through fairly quickly, so always feel free to ask me questions later. For questions 1, 2, and 3, each one of them was worth 2 points, 1 point for what I underlined. So initial position is 3 meters, 1 point for initial position, 1 point for 3 meters. And similarly for 2 and 3. For 4, 5, and 6, you got 1 point for the correct symbol, and then 1 point for the correct unit. For number 7, this one was worth 2 points. One thing for talking about it being constant, and the other one positive. Velocity or speed was fine. It's really important that you only describe the motion, not the graph. Several of you ran into trouble where you said, well, it's going up, and that's referring to the graph. We don't know what direction the object is actually moving. For number 8, it was a 2-part, so you needed to have 2 different descriptions. The first part, constant and positive, speed or velocity, worth 2 points. The second part, positive but slowing down. Some of you said going towards rest, that was also acceptable. So there were various things that I accepted, but again, it was important that you were describing the motion, not the graph. So this first page, total of 18 points. All right, number 9. So for this one, I know I did not fill in all of the answers or all of the responses. 2 points for the answers, 2 points for the method. So the answer that I was looking for was this speed was 30 meters per second, this speed was 16 meters per second. For the methods, you could either count the number of squares and realize that this was 15, this was 8. This was 34. If you did Pythagorean theorem, you would find that the hypotenuse should be 17. 34 is twice 17, so everything should be doubled in order to get velocities. An alternate method is to just use trigonometry. You can measure this angle with a protractor at 64 degrees and then use trig functions to get 15 and 30. So either method was fine. For number 10, you needed to draw an arrow that went from the tail of the first to the tip of the second. So that was worth 2 points, an arrow, both line and arrowhead in the correct direction. And you also had to give the magnitude and the direction. So again, count 20 here, 21 here. Use Pythagorean theorem to figure out that the length of this line is 29 centimeters. And then you can either use trig or measure with a protractor to get 44 degrees. Okay. 9 through 12. Should have been 11 through 14. Have multiple possible answers. Generally for each one, it was 2 points for labels, 1 point for the graph, but as I said, there were many options. So for this first one, draw a graph that shows accelerated motion. I did a position versus time graph with this going up. Basically, you just need to show that the slope is getting steeper. Number 2, draw a graph that shows an object turning around, and so positive velocity, negative velocity. Velocity versus time graph. Again, not the only possibility. You could have done a position graph as well with either a valley or a hill. This one was 1 point only because all I wanted was for you to show me that you understand increasing negative slope looks like this. And so I don't have any labels because it works for any graph in the universe. And then draw a graph that shows positive displacement. Again, there were numerous options. What I did was velocity versus time. We know that the area under this graph is going to be positive, and the area is the displacement. Also worth 3 points. Okay, number 15. Include all your work. So I was looking for you to fill in the variables that you know, and then use this calculation. Acceleration is change in velocity over time. This was my change in velocity, and so I just, 4 was my seconds, and so I just do the calculation to get 4.5. And then I know that I can get displacement is the average velocity times time. Again, usually there are multiple ways to solve problems. This just happened to be how I solved it. So you get 4 points for your work, and then 2 points for each of the blanks. So, well, not 2 points each. You get 1 point for each blank, so it's 4 points altogether. Okay, analyze the free body diagram. So we need to look at the direction that the person is going, and they are falling down. The speed is decreasing. So I need to remember that in order for speed to decrease, the velocity has to be in the opposite direction from the acceleration. So if velocity is down, acceleration is up. That means my net force has to be up. I know it's 200 newtons, and so that means 900 up, 700 down. For this one, the elevator is moving upwards, but the speed is decreasing. So if velocity is up, acceleration is down. And that's only true if the downward force is bigger than the upward force. And so that's why we subtract the 60, because this will then give us a 60 down, which means acceleration will be down. Okay, car initially traveling 7 meters per second. I have my variable list. The only thing I can fill in is 7. I should put in my meters per second. And so that is not enough information to tell me anything other than the initial velocity, because literally nothing else is filled in. Number 20. Okay, so for number 20, I'm going to do my usual procedure. I've got my list of variables. I'm going to substitute in what I know. I know initial velocity, final velocity, and the displacement. From these two, I can calculate my average velocity right here. So average velocity is add the two velocities and then divide it by 2 to get an average. And then I use this equation that displacement is the average velocity times the time. And I solve for time. 140 over 60 gives me 2.33 seconds. And as before, every single blank is a point. Okay, then for this one, I have a velocity versus time graph. And right is defined as positive. All of the velocity values are positive, so that means that it's traveling to the right. I know that it is decreasing in speed because I'm going from 6 to 2. I should say decreasing speed. And then my distance traveled is the area, so I calculate the area. I've got a rectangle, which is 60 times 2 is 120 meters, plus a triangle, 1/2, base is 60, height is 4. So rectangle plus triangle to give me total area of 240 meters. And so 240 meters, and then the final speed, I just read off the graph. Final speed is right here, and that is 2 meters per second.